Good morning, everyone. Welcome and thank you for joining us for the AI-powered build, generative design, robotics, and automation in the future of construction. My name is Joe Broon. I'm the Managing Director of Building Digital and today's host of this online micro conference. Today's session explores one of the most important shifts our industry, every industry, has ever faced. How artificial intelligence is moving from theory into real-world application across the entire construction life cycle. From generative design tools that reshape how we conceive buildings to robotics and automated systems that are transforming how we physically construct them, AI is redefining what's possible. Across this session, you'll hear from leading innovators working at the cutting edge of design technology, robotic fabrication, and intelligent systems. They'll share practical insights, real-world applications, and forward-looking perspectives on how these technologies will shape the future of architecture and construction. Right, we move on to Shirin Dora. Shirin is a senior lecturer in Neuromorphic Computing at Loughborough University, specializing in next-generation AI systems inspired by the human brain. Her research focuses on energy-efficient adaptive computing architectures that have significant implications for robotics, sensing, and real-time decision-making in complex environments. Shirin brings a unique perspective on how emerging AI paradigms, such as neuromorphic systems, could shape the future of intelligent construction technologies. Shirin, over to you.
Thank you. First of all, thank you for inviting me to speak here. I won't go in too much into the neuromorphic side of things because I think it's going to be too much for a 10-minute talk, but I will talk about AI in project controls. So a quick overview of my background. I did my PhD at Nanyang Technological University, Singapore. This was way back in 2012 when AI was not something everybody was interested in so much. So I started in AI much before everybody picked up. Then I did a postdoc at the University of Amsterdam where I focused on bringing AI in machines closer to the human brain. After that, I moved to take up a lecturer position at Ulster University. And since 2021, I have been a senior lecturer at Loughborough University, where I have been supporting organizations in adopting AI in their workflows. And I'll talk about one particular example today. So to start with, I want to briefly touch upon how much investment has gone into infrastructure sector over the last couple of decades. So this is a infographic from about 2015. It's old, but it's still relevant. And it actually said that the investment that the infrastructure sector has received has doubled or is going to be double of what it was in 2015 compared to what it's going to be in 2030. And this, when I looked at the recent stats, it's going to actually exceed the double mark. It's going to be much higher than that. And there are multiple reasons for this, including aging assets, climate change. So climate change has led to a lot of investment going in resilience, a lot of investment going in sustainability, new materials, and all of this has resulted in increased investment. And then digitization, which has been kind of accelerated by AI. Despite all these investment, the productivity in the sector hasn't matched up with the increased investment. And construction is a sector where the increase in productivity has been much more slower compared to other sectors like manufacturing. And AI over here has the potential to actually change things and increase or improve the productivity in the construction sector. And the infographic I show on this slide is basically an illustration of the fact that AI is not just about LLMs. There is an AI beyond LLMs. And the reason I highlight that is because from an industrial perspective, many people think that LLMs are like the Swiss Army knife of AI. But what I would like to argue is that there are AI consists of LLMs, machine learning, computer vision, robotics, and a lot of other techniques that some of other speakers have mentioned already today. And it's very important to use the right technique for the right problem and in order to get the best benefits of AI. So RISC did this survey and looking at what are the different problems where AI can actually bring in the benefits in the infrastructure sector, including if you, what I would like to do is like focus your attention to the top five where the significance is much higher compared to the other sectors. So progress monitoring, project scheduling, resource optimization, contracts, and project document review. So these are one of the sectors. These are some of the sectors which have the potential to receive maximal benefit from AI. I'm going to talk about a particular use case that focuses on the contracts and project documents review. Um, and this is so I did some work with a company, Constructor.AI, which what it does is essentially processes project documentation to foresee real-time issues and blockers. So this is different. Like often people confuse this with the problem of risk management, but this is different from that in the sense that the company looks at um, real-time documentation that is produced in the project in order to identify ongoing issues and blockers and foresee them before they start impacting the project, causing delays, causing cost overruns, causing rework. And what they do is they don't just extract or detect these problems, they try to track them across the document. So once they are detected, they try to track them across the documentation. And the idea is that because construction is one of the sectors where there is so much information that uh, it becomes difficult at some point to keep up with the information and not be overwhelmed by it because of the so many stakeholders involved. And this is where what Constructor does is it detects the issues, tries to track them across documents. So the people who are managing the project, who are looking after the project, don't have to spend time finding the information, but that it's readily available to them already through AI. And what it does is then it tries to actually predict the impact of these detected issues and blockers by connecting this information across the documentation. So think of it this way that somebody writes a site diary on a project. What Constructor.AI will do is it will detect any issues that are reported in a particular site diary, connect that information with the program, with the CBS, with the BIM models, and try to already predict, okay, this is going to be the cost impact, this is going to be the time impact, this is going to be the contractual implication, without actually you looking into the contract or looking into the other documents in order to identify the impact. So what I did for them was basically Constructor.AI relies strongly on AI for its functionality, and this is where I come in. So what I helped them develop was agentic AI workflows to integrate information across the documents. So as I said, that it's not just about detection, which LLMs can do very well, but then the challenge is about integrating that information in a reliable way across the documents. So you're extracting information from the different documents. How do you connect them to the same issue eventually? So these are the agentic AI workflows I developed for them. Then, when it comes to predicting the impact in terms of time, cost, contract, then again, this is where machine learning was actually used to predict the impact. Then and at the end of it, like most of the sectors already have some user facing platforms in place, and how do you integrate these AI based algorithms with existing platforms? So you don't want to have like a separate pipeline of AI algorithms that work completely independently, because then you don't leverage what you have built so far. So what I did was essentially allowed them to integrate these platforms, integrate the AI algorithms with the existing platforms so as to best leverage the data that is already being generated by the platform in place. So I was also involved with Constructor.AI in a case study that was done in Sao Paulo Metro in Brazil, which is a large infrastructure project. It involves 3 stations and tunneling works. The project was focused on Line 2, Lot 6. It's a multi-billion euros project. And one of the most challenging aspects of the project was the tunneling that was being done in the middle of the city, which is like very highly populated. It's a big city. It's one of the biggest cities in Brazil. These are some of the metrics from the case study. So the algorithms that I helped develop were actually able to detect all of the issues with 100% accuracy. There was some false positive rate. What that means is there was essentially a false positive rate of 14%. What that means is that they could detect all the issues and blockers, but there were some false positives, meaning they were detecting some issues which were not actual issues. They were also able to predict the impact in terms of the program impact. So precisely predict, okay, this issue and blocker is going to affect these activities in the program. This is how much the delay is going to be. So they were also able to do that, and the accuracy in this case was 86%. And the lower accuracy in this case was due to the fact that some of the accuracies were not named on the program in a way that was easy to link them with the specific issues. So for example, if there was an activity about pavement, it uses an abbreviation of PAV, which is not very apparent to AI. So this is something that still needs some work in order to allow AI to actually understand the abbreviations used. Then there was 100% accuracy in tracking the progress, tracking the issue across the different documents. So what that means is that if an issue was mentioned in a site diary, then referred again in a minutes of meeting, then referred again in an email, then all of these documents were analyzed to detect the issue, the relevant information, and then relate it back to the same issue automatically, all done using AI. And the benefit of this is, think of it in this way, that when you are using the platform to ask questions, you can simply ask questions to the platform. Okay, this issue, what has been done, what's the status? And you don't have to go and look for the right document. The platform finds the information, presents it to you by extracting it from the right document. So this is one of the examples that I did. This is just one example of the work I have done with Constructor.AI on applying AI to their ongoing platform. If you are interested in working on this, I can also provide support in terms of identifying the right approaches in AI to solve your problems. I'm always looking for a challenge, and integrate AI. Or if you're interested in integrating AI into your existing solutions, I can support with that. If you're already using AI but struggling to get the clean data, then that's something that I can help with as well. And if you're interested in building an AI strategy, organizational level AI strategy, to identify, okay, which are the low hanging fruits for your ongoing user facing platforms, that's something I can help with. And if you're interested in securing government grants to really realize your AI ambitions, that's also something I can help with. Thank you. I'll stop here.
Thank you, Shirin. Very interesting stuff. Thank you very much for your presentation. Got a couple of questions of my own, but before we get to that, I'd like to open up for questions from our attendees. Please feel free to fire over a follow-up question for Shirin. We've got a question from Alexi on the chat. It's in knowing AI limitations in context lens, how do you manage hallucinations and arrive at reliable results across large data sets on, for example, large projects?
So hallucinations, yes, I agree, they are a problem with LLMs, but they were a much bigger problem around 2022, 2023 when LLMs first came out. They are not a bigger problem right now. Uh, for example, when the case study I presented, the 14% additional issues that were detected by the LLMs were issues not in the sense of hallucinations, were issues in the sense of, for example, if one of the documents said, so there was an Aconex document that said that attachments shouldn't be bigger than 10 MB. So then LLM picked up it as an issue, but this is not a construction issue. So these are the kind of issues I'm talking about that were false positives, but we didn't get any hallucinations. And a lot of it comes down to how you design the prompt right now. At least LLMs have been updated now over the last couple of years to actually manage hallucinations very well. So in short, we didn't observe any hallucinations in the case study we did. Was there a second part about large data sets?
It's just, for example, when you work on a large project and you obviously when you arrive at reliable, or you think of reliable results across large data sets.
Yes. So the way the platform is designed is, so I agree that AI makes mistakes, and we need to kind of like guard against those mistakes. So the platform is designed in a way that it presents its predictions to the platform, and at the end of it, the user has to confirm that, okay, yes, this makes sense. Yes, this makes sense. Yes, this makes sense. So AI doesn't make any decisions by itself. It's until unless Like, so we look at the confidence in the decisions, and when the confidence is very high, only then those decisions are led through. Otherwise, it's the user who takes the final call. So there is a human in the loop paradigm that the platform has been designed in mind with.
Okay. Alexa follows up with what are some good prompt design? So what are the best practices for good prompt design from your experience?
So some of the things that I use in my approaches is, for example, there's something called as role prompting. So what you try and do is you tell the LLM to essentially think like a construction engineer or a supervisor. And so like to answer this question a bit more technically, LLMs are essentially uh, language models that are modeling a probability distribution. And they basically, when you give them a context like, okay, construction engineer, then they will go to the part of the probability distribution that captures everything about being a construction engineer. So by saying that behave like a construction engineer, you are narrowing down to the space of the probability distribution, which is what construction engineer is going to look at. So that helps with narrowing down the results that you obtain from LLM. Then the other thing you can do is that you can use ideas. So for example, if you have a document and you already have some examples that issues would be mentioned with statements like delays, so you can give basically some examples. For example, you could give an example in the prompt: the progress was delayed by rain. So when you give this an example, this helps LLM understand what kind of semantics you're looking for, and that again narrows down the result to specific things. And there are other tricks you can use. For example, one thing that Constructor.AI did was like use different prompts for different projects. Having a single prompt for all the projects that doesn't work very reliable because the examples are different, because the documents are written in a different way. So using different prompts for different organizations help improves the accuracy a lot. So these are some of the tricks you can use to actually go beyond the problems that LLMs are still struggling with.
Okay, interesting. Amazing stuff, Alexi says. Just wonders if any if you can get any more granular, any more specific um, with role prompting.
So I think like the example I gave earlier, that you start your prompt by saying you are a construction supervisor. That's exactly what we do in our prompts. So what Constructor.ai did it in prompts. So what they say is they basically start the prompt like that in order to narrow down the distribution. So the idea is to think about how LLMs work and try and narrow down the distributions. So the more techniques you can use to narrow down the distribution for the LLM to look at, uh, the more accurate your answers will be. So we literally actually use this prompt, this statement to start with, and we observed that there was significant improvement in the accuracy of the detected issues just by adding this line.
Okay. Um, yeah, I'm thinking just how well does it integrate with existing project management tools, and what project management tools does it particularly integrate well with?
Do you have an example in mind?
Like, I don't know, Primavera.
Yes, so in case of Constructor.ai, they have like third-party integrations with Primavera P6, the MS project, and they're building on some with Econex. So the idea is that, so the idea behind Constructor.ai is that they try and impose minimum training, minimum changes in existing workflows. So they integrate directly with the tools, get the documentation where it exists already, and detect the issues and show them in the platform, the web platform that they provide. So it integrates with most of the tools out there. There are startups, they're open to integrate with other tools. If that's something that the other companies, that the clients are interested in using. But yeah, so just to answer your question, yes, it does integrate with the majority of tools that already exist out there.
Okay. And apologies if you've already covered this, Shirin, but how do you address privacy and data security when processing sensitive project documentation?
So, I mean, the company follows the usual policies. I mean, they are cyber essential certified. They follow the regulations. the usual policies. The data across the project is separated in the backend across the different schemas, which makes sure that it's not there is no leak, there is no exchange of data across the different projects. The models are individually built for different projects, so they do, again, the data is not shared across projects. So these are basically the policies that are relevant for when you're building AI models, how to make sure that the data doesn't leak from cross project across into the AI models. So these policies are used by the organization.
Before we wrap things up, have we got any more questions for Shirin? Gillian, yes.
Just lastly, Sharon, I hope you don't mind this question because it's quite broad. But what's the one thing in construction, maybe just to wrap up this conversation, that leaders should be doing now to avoid being left behind on AI?
So I think the way, so as I said in my last slide, in my second last slide, the right now, I think if we think about making big changes in the short term, they are much harder to do. So most of the organizations already have an IT infrastructure, already have people using those IT infrastructure. So it's not about starting from scratch. It's about how to integrate AI with the existing infrastructure, build on top of it, rather than revamping everything. So what I would suggest starting with is identifying the low-hanging fruits. You already have a user-facing interactions going on, which is generating a lot of data. So the starting point that I would think would be start slow, look at the data. What problems can you address using AI from that data? How can you improve the user experience from that data rather than thinking too far outside the box? Because once you have these small wins, once you have these um, low-hanging fruits, you already have a good understanding of what is possible with AI, like what is not possible with AI. So this would be a risk-free approach, good place to start. Short-term gains are possible. Clients are going to, you will be able to tell your clients that we are using AI. So it's kind of already a win, puts you in a win-win position. And as you start doing that, it helps you, it gives you the knowledge to think about the longer vision to, okay, what should be the long-term vision of the company in terms of this is possible with AI. This is how we should do things from now onwards. So we are best positioned to leverage AI 5 years or 2 years or whenever, whatever aligns with your long-term vision. So this would be my approach. And in the process, you learn about AI as well, and you are much better positioned to exploit the benefits that AI provides. Does that answer your question?
Yeah, definitely. I think it's like with any industry, as I guess you start with the little gains and then you start to learn and learn as you go.
Yeah,
Similar to AI, funnily enough, it learns and learns as it goes forward, doesn't it?
yeah,
So,
yeah.
thank you.
Thank you, Shirin, for a great presentation. I'll take the opportunity, before we wrap up completely, I'd like to briefly reflect on our four keynotes today and some of the key insights from today's session. Firstly, we heard from Cesar Fagachan Pinzani from Alta. Cesar showed how AI is transforming early stage design through digital twins, configurators, and automation. His platform enables real-time exploration of building options while staying connected to cost, materials, and delivery constraints, which in turn helps to bridge the gap between design and reality. He also highlighted a key challenge, adapting to different workflows across practices and driving adoption. Alta's approach combines open source AI with bespoke solutions supporting everything from student housing to customized residential projects. Our second keynote was Molly Claypool from AUAR. Molly reframed housing as a manufacturing problem, presenting AUAR's robotic microfactories that bring production directly to the site. These portable systems deliver factory quality timber construction without the need for permanent facilities powered by software that link design straight to manufacturing by combining robotics with physical AI. AUAR is improving speed, cost, and scalability, offering a practical new model for delivering housing at scale. We then moved on to Loris Di Natalia from Zurich Soft Robotics. Laura's introduced Solskin, a responsive facade system using soft robotics to optimize energy, daylight, and comfort in real time. Rather than relying on complex rules, the system uses AI to learn from user behavior and adapt over time. Built with resilient pneumatic components, it offers a flexible and modular approach to intelligent building envelopes, while highlighting the broader challenge of balancing user needs, energy goals, and system integration. And then we just heard our final presentation today from senior lecturer at Loughborough University, Shirin Dora, who focused on AI and project controls, showing how it can transform how we manage construction data. His system, Constructor.AI, connects information across documents to detect risks early and predict their impact on time and costs. It shifts teams from searching through information to simply asking questions and receiving clear, actionable insights. Shirin's case study presented strong accuracy, pointing to a real opportunity to improve decision making and productivity across projects. So, thank you for attending today's micro conference. I think taken all together, today's speakers have shown that AI is not just a future concept, it's already reshaping how we design, build, and manage the built environment. The challenge now is how quickly and effectively we can adopt these tools to unlock their full potential. Thank you again to all our speakers and to everyone who joined us today. Please do keep going back to buildingdigital.com. Enjoy the rest of your day. Thank you very much.